Hey everybody, today I'm going to talk about cylinders and how to find the surface area. And you can see I have several cylinders here for you. I can move them out of the way. Hydro flask, disinfectant wipes, Sharpies, toilet paper roll empty, toilet paper roll full. But my favorite example is one that I've had for years and years and years in my classroom. I don't even know where it came from, but here's a cylinder and you can see that it has a base that's a circle. So it has this base here and this base here. So cylinders have two circle bases, and then the lateral surface is just a giant rectangle. So you already know all the parts of a cylinder. We just have to find the surface area. It's basically two circles and a rectangle. In 6th grade, I believe you may have seen it like this. I don't know. You use a lot of nets in 6th grade. 7th grade, we have a lovely formula to use, and I'm going to work you through some of that stuff right now. These are the notes I have for you in Google Classroom if you want to follow along. Let me make sure you can see. I can zoom it in a little bit. Okay, how do you calculate the surface area of a cylinder? Using a formula. So you can see that you have the circle top and bottom, and then your lateral surface. We call it a surface, not a face, because it's not flat when it's in a cylinder. It's just a surface. Okay, the formula is 2 pi r squared, because we know that pi r squared is the area of a circle, and we have two of them, the top and the bottom bases. And then 2 pi r/h. When we derived our formula for area of a circle, we kind of talked about the relationship between the radius and the height and all that good stuff. So that's the formula that we can use. So if I have this example here, make sure you can see. Find the surface area of the cylinder, round your answer to the nearest tenth. We're going to round to the nearest tenth, and we're going to use 3.14 for pi. Okay, when we're doing formula work, I always start by writing my formula. The more you write it, the more you'll know it. So it's surface area equals 2 pi r squared plus 2 pi r/h. Again, here's the area of your two bases. Here's the area of your lateral surface. And then you just substitute everything in. Leave everything in terms of pi until the very end. So this is going to be 2 pi. The radius is 4, so 4 squared, plus 2 pi. Again, the radius is 4 and the height is 3. I'm sorry if this marker is not working so well. I will change it up. Then we can simplify this all out. 4 squared is 16. 16 times 2 is 32 pi, plus 2 times 4 times 3 is 24. So this is 24 pi. So this is your lateral surface. This is the area of your bases. And sometimes you just want to find one or the other. For this particular problem, we want to find the whole surface area. This is equal to 56 pi. Now it's really nice and easy. You just substitute pi for 3.14. When I do this, I get 175.84. The directions say round to the nearest tenth. Let's remember how to do that. We're going to round down, so it is about 175.8 millimeters squared. So that is the surface area of this lovely cylinder right here. Two bases, lateral surface. Two bases, lateral surface. Let's step it up a notch here. This problem is just asking for how much paper is used for the label on this can of peas. So if we're talking about the label and the label only, then we're only talking about the lateral surface part of our surface area. So if I only want the lateral surface part, that's just 2 pi r/h. We just want the lateral surface. So it's not the bases. We don't want that top and that bottom. So it's S equals 2 pi RH, 2 pi, the radius is 1, the height is 2, 2 times 1 times 2 is 4, so it's 4 pi. So it's about, and there's no rounding instructions on this one, so we'll just put everything, 12.56 inches squared. So that's the area of the lateral surface. This would come in handy, you know, for food manufacturers. How much paper do they need? How big would the logo be, etc. Okay, so now we're going to step it up even more to this. Some of you might be big recyclers. I hope you all are. But this is a problem that we can talk about how much money you would get for a particular can of something. So it says you earn 1 cent for recycling the can in example 2. That's our can of peas here from example 2. How much can you expect to earn for recycling the tomato can, which is clearly bigger, not just in my picture, but with dimensions. Assume that the recycle value is proportional to the surface area. All right, so, well, we need to find the surface area of each of them before we can move on. So I have tomatoes, I'm just gonna write Tom. So surface area is 2 pi r squared plus 2 pi RH. And let's put all of our values in. 2 pi, the radius is 2. 2 squared is 4. Plus 2 pi, again the radius is 2. And the height is 5.5. Yes, that is my phone dinging. Equals 2 times 4 is 8. So 8 pi plus 2 times 2 times 5.5 is 22 pi. This is equal to 30 pi. I'm going to leave it just like this because in a little bit we're going to set up a proportion. And it's a lot easier to leave things in terms of pi that way. So now I'm going to find the surface area of my can of peas, which we've already done part of it. We have our lateral surface up here, but now we need to include our bases. So surface area is equal to 2 pi r squared plus 2 pi RH. Bet you guys will have that memorized super quick. Equals 2 pi. Again, my can of peas were up here. The radius is 1. We know that 1 squared is just 1, so I'm going to put that there. Plus 2 pi RH, that's 2 pi 1. The height is 2. Simplify this all out. 2 times 1 is 2, so this is 2 pi. 2 times 1 times 2 is 4 pi. 2 pi plus 4 pi is equal to 6 pi. Obviously, we would include our units, so the tomato is 30 pi inches squared. Our peas is 6 pi inches squared, but these aren't our final answers anyways. So if the cost for recycling or the reward for recycling is proportional, we can do, you know, my favorite thing and set up a proportion. Okay, so I know that the surface area over the value is proportional. I'm going to set up my words first. Okay, so I know that the peas were 6 pi inches squared. I'm going to keep my units off of my proportion just to make it easier. And for 6 pi inches squared, I got 0.1 cents. Now, for my tomato can, it's 30 pi, and I don't know how many cents, so that's our unknown. And then you guys know how to solve a proportion. You just cross multiply. So this is 6 pi times x, which is just 6 pi times x is equal to 30 pi times our 1 cent. And now I can divide both sides by 6 pi. Those cancel out, leaving me, sorry, I'm running out of room. X is equal to 30 pi divided by 6 pi just turns into 5 because pi over pi is 1. So now I have 5 times 1 cent, so x is equal to 5 cents. So the value that we can get for our tomatoes is 5 cents. So clearly it's a bigger can. So surface area of cylinders, let's go over it. We have a circle base, a circle base. So 2 circles. Pi r squared, which is why we have the 2 pi r squared. And then the lateral surface is just a big old rectangle. Okay? Hope this helps. See you soon.